Hi, everybody. Good morning. Today is, bless you, April 10th. So today we will finish 9.5. And then Friday we will start 10.1. Okay. So, yeah, I have graded your quiz 4 and quiz 5. Let's go over them at the end of the class. So Friday, please print out the worksheet 10.1. Okay. So let's continue. So 9.5 is about solving trig equations. The first thing you do is you look at the types of the trig functions. Are you able to reduce the number of types of the trig functions using trig identities? And then you also look at the angle. You want to make the angle be the same. But for some problem like this, see, you have different types of trig functions, but the different angles. So you use the double angle formula to make the angle be the same. After that, you realize there is a common factor. Yes, everybody? When we factor out the common factor, then we get two mini equations. So we don't need to change the two trig functions into one type. Right, everybody? So it might happen like that. You get a product of factors equal to 0, and each factor is about different trig functions. That's okay. Okay, so you don't always have to change the type of the trig functions to the same. Okay? Yes. Okay, so let's continue. Number 9. Okay, we have sine and we have cosine, and they're related. But do you see the angles are different? You see the angles are different. Well, last example, this was a double angle, and this example, this is a half angle. Right, everybody? So we want to make the angle be the same. We need to use the formula. So formula right here. We have half angle. So we use the half angle formula. Okay, so which one shall we use? It's about cosine. Okay, so let me print screen here. This is the cosine half angle formula. Okay. Now we can use this. And what we have is the cosine square of x over 2. So it's like, okay, your theta is not theta, we use x. And we want to square it. The good thing about the square, it can get rid of the square root. Right, everybody? So we get 1 plus cosine x over 2. And the square root is gone. Right, everybody? By the way, if you missed some class, make sure you print out the notes and take notes. Print out the worksheet and take notes. If you don't understand some problem or some steps, please come to see me. I want to make sure you understand every problem in the notes, in the homework, and in the practice exams. Okay, so we're ready to plug in. Therefore, we have the left-hand side, 2 minus sine squared. The right-hand side, 2 times the cosine square is 1 plus cosine x over 2. Is that okay, everybody? Oh, do you see the 2 cancel? Yes. And we got 2 minus sine squared is 1 plus cosine x. Okay. So the first thing, we change the angle. Make the angle the same. So either use double angle formula like the previous example, or this example, use the half angle formula. Okay, so make them the same. And then, okay, look at these. We get the equations. Let's move all terms on one side. All right, so let's subtract 1 on both sides and also subtract the cosine x on both sides. Then you get, what is 2 minus 1? 1. So we get 1 minus sine x squared, and we also have subtract cosine x equal to 0. Right? Yeah, this is our common rule. We want to move all terms on one side to see if you can factor. Okay, if you get a quadratic type, okay, see if you can also factor it. But do you see we're not able to factor right now, and we have sine, cosine, we have two different types of trig functions. Everybody? So this is different than the previous problem. The previous problem, we move all terms to the left, but we have a common factor. Yes, do you see that? We have a common factor. So we have a product of two factors. We get the mini equation. We don't have to convert the sine into a cosine, right? But this is last problem. This problem, are we able to factor here? Nope. Nope. So in this case, we have to convert either the sine into cosine or the cosine into sine. And then this step, we need to use the trig identities, which is sine squared plus cosine squared equals 1. Yes, everybody familiar with this trig identities? And there are alternate form. The sine square is 1 minus cosine square, and the cosine square is 1 minus sine square. So they are alternate forms. Okay, so look at this problem. Which one we should use? So there are two ways. You either express the sine in terms of cosine, right? Or you express the cosine in terms of sine. Let's compare both ways. If you express the sine in terms of cosine, do you see here the sine square is 1 minus cosine square? And then you just get something like cosine square here. Okay? But if you express the cosine in terms of sine, do you see we have the cosine square? Yeah, you need to introduce square roots. Do you like square roots? No. See, even though there are two ways to continue, we compare them and we realize it's better to change the sign in terms of cosine. Okay? So change this. Therefore, what is sine squared? So usually when you see the sine square, you use this formula. And then you plug in 1 minus cosine squared. Okay? And next term, negative cosine x equal to 0. So far, so good, everybody? You plug in the sine square is 1 minus cosine square. This is more general. So if you have some other number or some multiple in front of it, this is what you do. Okay? But some of you might realize, hey, we have 1 minus sine squared. Can we just put this guy equals cosine squared? Yes, you can, but only for this problem. Okay, the more general rule is to replace the sine squared by 1 minus cosine squared. Then no matter what number in front of this is, or whether you have a constant multiple, this method works. Okay. And now we distribute. So it becomes 1 minus 1, and then negative become positive. Right, everybody? Thank you. it becomes positive cosine squared minus cosine x equals 0. Right, everybody? So the 1 cancel. We get cosine squared minus cosine x is 0. Again, if you miss some notes, or miss some class, make sure you print out the worksheets and write down the notes. And then you can also review your notes, like which step you don't understand, come to ask me. And remember, at the end of the semester, you can show me all your notes. Then you can receive extra credits, the 1% note-taking bonus. Okay. And now let's factor it. Do you see we have a common factor cosine x? After we factor out the cosine x, what's left? Yeah, cosine x minus 1. Good. We see the product of two factors equal to 0. We let the first factor is 0 or the second factor equal to 0. Oh, when you solve for the trig function, what happened? Equals 1. Okay? Yeah, so after you factor or and you get the you solve for the trig expression. So the trig expression is on the left-hand side by itself. And finally, we find the x. So in this case, you need to draw the trig graph. So here, we have cosine x. What is the graph of cosine x? Yeah, wave starting at 1. Okay. Everybody familiar with the trig graph? Yeah, practice a lot. Okay. So period is 2 pi, and it's a wave starting from 1, so like the slide. And then you have all the important angles. Okay. Again, if you miss some notes, please print out the worksheets and take notes. Okay. And now let's see. Cosine x is 0. So y is 0, which is here. Thank you. And do you see the points? The x values is the pi over 2 and the 3 pi over 2. You see? Cosine x is 0. So y is 0. What's the corresponding x? Those two numbers. Can everybody see that? So we have the x is pi over 2, but find all solutions. So not only the solution within this range. And again, what's the period of cosine? 2 pi. So what do you need to add? Exactly, 2k pi. And the other solution is 3 pi over 2. And you also need to add 2k pi. Is that okay, everybody? Questions? Why don't you also put... Oh, we haven't done yet. Oh, sorry. Yeah. Okay, yes. We haven't finished. The next one, we have the cosine x equals to 1. So where's 1? See? Here. And that corresponds to the x is 0. Okay? Yeah, you're right. So 0 plus 2k pi. And can you see the other solution, the 2 pi, is also included here. Because when you let k equals 1, you get the 2 pi. Okay? So you don't have to put 2 pi plus 2k pi. It's included here. Or you can just put 2k pi. Okay? So therefore, we have all the solutions to this trig equation. Any questions? All good? Okay. All right. Let's continue. Yes. So for those of you coming late, please take notes and watch the recording. Okay. And try to come to class on time because then you don't miss something. Our class is going to be very quickly. The pace is fast. Yes, so try to come to class on time. Okay, next problem. So we have done many examples about the sine, cosine. This problem is about the tangent. Okay, let's see. We only have one trig expressions. Okay, so we can solve for the tangent. What do we do? Yeah, leave the expression here. And how do you solve for it? Yeah, subtract 3. Exactly. So 3 times tangent x over 2 is -3. Right, everybody? And then divided by 3. Oh, see. Okay, so we have the tangent x over 2 equals -1. Yes, everybody? We isolate the tangent. We're ready to draw the graph. Okay, what is the graph of tangent? Like x cubed. But what's the range? What's the domain? It's from negative pi over 2 to pi over 2. Right, everybody? And the common angle values, the middle is pi over 4. And tangent pi over 4 is, what is that? Yeah, tangent pi over 4 is 1. And then you cut this into 3 pieces. The left is pi over 6, and the right is pi over 3. And then okay, a smaller number here will be what? What's tangent pi over 6? 1 over root 3. So this is 1 over root 3. And then here, this one is root 3. Those are the common angle values. Right, everybody? Okay. Now, look at this. The angle is not exactly x. So let's call this theta. And let's call this is tangent theta. And we are looking for when tangent theta equals -1. So look at this picture. This is 1, then this point is -1. So put the -1 here. And then, what can you say? Yeah, this point is negative pi over 4. Right? So the theta is negative pi over 4. And this is just one solution within the interval negative pi over 2 to pi over 2. How about all the solutions? What's the period for tangent? Pi. So the period for tangent is pi. So in order to get all solution, you need to add k times pi. Is that okay, everybody? So sine, cosine, secant, cosecant, period 2 pi. So in all solution, you add 2k pi. But for tangent and cotangent, period is pi. If you want to get all solution, you add k pi. Is that clear? Here we want to find beta or x? X. We want to find x. Okay? So no matter what angle here, you just call it theta because you know the graph of tangent theta. So after you figure out the theta, you can come back Yes. So theta is x over 2. How do you solve for x? Multiply by 2. So 2 times whatever above. Do you see when you distribute? What is 2 times negative pi over 4? 2 pi over 4, which is pi over 2. Yes. So 2 pi over 4. The 2 and 4 cancel. You get the 2 in the denominator. And then plus what? 2 times k pi. Is that okay, everybody? Mm-hmm. So no matter what the angle is, it could be x over 5 or x over 10 or maybe 7 times x. You just call it theta and draw the graph of tangent theta. After you figure your theta, set that equals to the angle and solve for x. Is that okay, everybody? Mm-hmm. Yeah. All right. Okay. Next problem. If you have sine 5x and sine 3x, you see this is a sum of two sine functions with different angles. We use the formula. What formula? Yeah, sum to products. Right, everybody? And it is the first one, right? Okay, so we have sine. Okay, maybe let me pre-screen these. Okay, pre-screen this and copy that. So that's why I said in this session, make sure you carry your formula all the time. You need it. Okay, so compare. We see the A is like 5x and the B is like 3x. Right, everybody? Mm-hmm. So on your left-hand side, it's the same as saying 2 times sine. A is 5x. B is 3x over 2. Cosine A is 5x. B is 3x over 2. Right? And the right hand side, you still have equals 0. Okay? Yeah. All right. Look in the parts. 5x times 5x plus 3x is 8x over 2, 4x. So simplify. 2 times sine 4x. And how about here? 5x minus 3x. 2x over 2. X. Ooh. See? Sum two products. When it's sum, we don't know how to solve it. But when it's products, we know how to solve it. Right, everybody? If you have a product of factors equal to 0, what do? Yes. So we have either the sine 4x equal to 0 or the cosine x equal to 0. So far, so good, everybody? Mm-hmm. All right. And now about the sine. We draw the picture of the sine. And by the way, because this is not exactly x, what do? You call it theta. Right, everybody? And what is the graph of sine theta? Wave starting at 0. Good. So let's say this is sine theta. And then you know the important point, pi over 2, 3 pi over 2. Everybody okay? Okay, now 0. So the y equals to 0. Okay, what happened with the theta? Do you see theta here is either 0 or pi or 2 pi? So you can put theta is multiple of pi. 0, pi, and 2 pi. So it's like k pi. You can imagine it's like 0 plus 2k pi and the pi plus 2k pi, but you can combine them and just put k pi. Is that okay, everybody? This is theta. And what is theta? 4x. Oh, so what is x? K pi over 4. Exactly. So this is the solution about sine 4x equal to 0. By the way, if you put like 0 plus 2k pi or pi plus 2k pi, you will get the answer maybe look different, but they're actually the same set of solutions. Okay? Next one, we have the cosine x is 0. So we need to draw the cosine graph. What is that? Yeah, wave starting at 1. Okay, and this is pi over 2, pi, 3 pi over 2. Okay. Are so good, everybody? Yeah, that's why you have a good foundation. Familiar with the trig graphs, and then you can solve the problem. Okay, so cosine x is 0. So this is cosine x. 0. Ooh, do you see? Yes, we got x is pi over 2. Yeah, or 3 pi over 2. And then you want to have all solution, you can plus 2k pi. But actually, you can combine them, okay? You can combine them and put x is pi over 2, just plus k pi. Why? Do you see that 3 pi over 2 is actually pi over 2 plus pi? Yeah, everybody? So you can combine them and only get this expression. But in the exam, if I get this, I don't combine them, do I get all the points? Yes, you get all the points. Okay? So I'm just showing you an alternate way to simplify your answer, but you don't have to. Is that okay, everybody? So the solution is this one or this one. Two set of solutions. So this is number 11. Any questions about this problem? All good? You have been quiet today. Do you understand so far? Yes? No? If you're not, please feel free to ask me. Okay. All right, next. So you see we have problems about sine, cosine, and the next tab is the problems about secant and tangent. You know, secant and tangent, they are kind of related. Using the trig identity, which one? The tangent squared plus 1 is secant squared. Okay, so you in exam you might see some trig equations involving sine and cosine, or you might see some trig equations involving tangent and secant, or you might see some trig equations involving cotangent and cosecant. Okay, everybody? So we use this trig identity. The tangent square plus 1 is secant square. Okay, now look at this. Look at this one. Do you want to express the secant in terms of tangent, or express the tangent in terms of secant? Yes, very good. Because if you want to express the tangent in terms of secant, by the way, this is the alternate form. You subtract 1 on both sides. But then, do you see you only have tangent? You don't have tangent square. So if you express the tangent in terms of secant, you introduce square roots. Do you like to see square roots? No, no one wants to see square root. That is why this problem we express the secant square in terms of the tangent square. Okay, everybody? Yeah, similarly, if my problem is like secant x minus 2 tangent x squared equals to 4. If I change the problem like this, do you want to express the secant in terms of tangent or the tangent in terms of secant? The tangent in terms of secant to avoid the square roots. Is that clear, everybody? You usually change the trig functions with the square. Okay. Yes. So those are when you solve more examples, you kind of understand what we should do. Okay? All right. So let's do that. Secant. Oh, by the way, let's use x as the angle. So secant x squared is tangent x squared plus 1. And then we have minus 2 tangent x equals 4. Everybody? Okay, good. We change all the trig functions to the same type, tangent. Now we move all the terms to the left. See if we can factor. So subtract 4, and let's reorder the terms from the highest power to the constant term. Okay, so tangent x squared. And what is the next term? Yeah, 2 tangent x. What's the constant? Yeah, minus 3 equals 0. Mm-hmm. Okay, do you see it's a quadratic type? Uh-huh. If you can factor right here, feel free to do that. Otherwise, you can use a u substitution and let the problem look easier. So if you let u be tangent x, what is u? What is the problem becomes what? U squared minus 2u minus 3. You use a u substitution and you can make the problem look easier. It's a quadratic type equation. Two method, either factoring or quadratic formula. So what are the factors of u squared? 1. So you get u and u here, right? And what are the factors of negative 3? 1 or negative 3 or negative 1 or positive 3. We don't know which one. Let's try the first one. So 1 and negative 3. Okay, we keep trying until it works. Multiply the outside, we get negative 3u. Multiply the inside, we get u. Ooh, when we add them, what happens? Negative 2u. Check. So this is the correct factoring. If you miss a sign, okay, if you get positive 2u is a negative 2u when you add them, then you know you're going to flip the sign. Right, everybody? Okay, good. So now we said we have a product of 2 factor equal to 0. We set each factor equals 0. So what is u? Negative 1. And what is u? 3. Right, everybody? Okay, I'm not enough space. I think we need to make some room here. Okay. All right. Make some room here. Okay. So now we talk about the trig function. What is the u? Tangent x. Right, everybody? Okay. Now we draw the picture of the tangent. What's the picture look like? X cubed. And the domain is, the interval is from negative pi over 2 to pi over 2. Right, everybody? We draw the graph of tangent. Now, find the x. So here, this guy means the y is negative 1. Okay? So here it means the y is negative 1. Okay? And what is this angle? Yeah, negative pi over 4. So x is negative pi over 4 because we want to solve all solutions. What's the period? Pi. So you plus k pi. Okay, so let me write it down. So if you see sine, cosine, secant, cosecant, your solution, you add a 2k pi because the period is 2 pi. But when you see tangent and cotangent, your solution, you're going to add the k pi. Okay, so that is because negative 1 is a common angle value. Next part, 3. Okay, so you keep in mind the common angle value is like 1 over root 3, and the root 3. Any number outside of this, not these numbers, are not the common angle values. So you can see here, 3 is not a common angle values. Okay, so for not a common angle values, you use the inverse trig function. Yes, everybody? So then x is inverse tangent of 3. Okay, because it's not a common angle value. Then you use the at tangent 3. And because all solution, you add k pi. Let's use the calculator. Could you use your calculator? Tell me what is at tangent of 3? 1.2490. Yes, keep 4 decimal places and then add the k pi. So in your exam, I don't guarantee the numbers are always good. Okay? If the number is not good, you use the arc tangent, or depends on your trig functions. Is that okay, everybody? Mm-hmm. Okay, and sometimes the solution might not just be the inverse trig function. You always need to look at the reference angle. Let me think about what problem I want to say. Okay, like this problem. Do you remember this problem? The 1 over 6 is not a common angle value, right, everybody? And then the arc cosine. The arc cosine only gives us one solution. The other solution, you need to look at the reference angle. Do you remember this problem? Mm-hmm. So be careful with that. Okay, good. Now we have seen a lot of examples of the trig, how to solve trig equations. Story problem. Let's do one story problem. Okay, let's do one story problem, and then the rest I will let you to read at home. Okay, let's do the number 12. Okay, An airplane has only enough gas to fly to a city 200 miles northeast of its current location. Okay, so this is north and that is east. Okay? Northeast of its current location. If the pilots know the city is 25 miles north, how many degrees north of east should the airplane fly? Okay, so we know here. Okay, this is the airplane. Okay, it wants to fly into that direction. And this is the city. It's 25 miles north of the plane. And then from the plane to the city is 200 miles. The problem, want to know how many degrees north of east? You know, this is east, right? How many degrees north of east? So you start from the east, and then how many degrees go to the north of this angle? So the problem is looking for the theta. Is that okay, everybody? Mm-hmm. Yeah, the airplane right here. It wants to fly a city 200 miles northeast. But yeah, this region is northeast, so we don't know which angle it is, right? But we know the city is 25 miles north of it. How many degrees north of east the airplane should fly? Okay, we get a right angle triangle, and this is the angle we're interested. So this is the what? Opposite adjacent hypotenuse. Which one? Opposite. And how about the 200? Hypotenuse. And which trig function relate the opposite and the hypotenuse? Sine. Yes, everybody. Sine theta is opposite over hypotenuse. Opposite is 25. Hypotenuse is 200. Okay? And now your theta will be the inverse sine. So arc sine of this number. And what is your unit? Degree. So everybody take out your calculator and use degree mode and type this in your calculator. What do you get? I'm scared. Okay, what do you get? Thank you. Oh, sorry. 180 what? 8. Thank you. Degree. Do you have the same answer, everybody? Mm-hmm. So the remaining two problems, I will let you to read at home. Okay. The solution is on the website. Because we're behind schedule, we're not able to cover all the problems in your worksheets. Next class, pre-nav session 10.1. So right now, let's look at your quiz. Okay, so quiz 4, you took it last Friday. And number 1, many of you get this right. So if you have a negative angle, remember secant and cosine, they are hungry, they eat the minus sign. Right, everybody? So when you see negative angle, carry on that first. But all the other sine, tangent, cotangent, cosecant, when you see a negative, you can put a negative in front. Right, everybody? And then express everything in terms of sine and cosine. And then you distribute, cancel, and then you realize, oh, that equals the right hand side. Okay, that is the number 1. Number 2, you are given tangent x and sine t, and they are both in quadrant 3. Quadrant 3, the problem tells you is in quadrant 3. So you draw the picture like that. Do you see your x is negative and the y is negative? So then, because you're given tangent, you know the x and y, and then you can find the r, right? And your sine x is y over r, so you get negative. Many of you put positive, no, your x and y are both negative. And then here, you have your y and r, and then you find the x, because in quadrant 3, your x is negative. So you also get cosine t. Then you plug in cosine x plus t, use the sum formula, and you plug in. And at the end, please simplify your answer. So you have your denominator be the same, and then write down the numerator. Okay? So this is number 2. Any questions of number 2? Okay, let's look at the quiz 5. So quiz 5, the first problem, it does not give you which quadrant. Then you have to figure it out. Cotangent. Cotangent is x over y, right? It is positive. It means the theta is either in quadrant 1 or quadrant 3. And the cosine is x over r, but it's negative. Your cosine x is negative, either quadrant 2 or quadrant 3. And you compare them, you see the angle must be in quadrant 3. Okay? And again, similar to what we did, x over y, and you know x and y are both negative, you can find the r. After you find sine theta and cosine theta, use the double angle formula to find sine 2 theta and cosine 2 theta. By the way, the tangent 2 theta, you don't need to use the tangent formula. You can use sine 2 theta over cosine 2 theta. It can save you some time. Is that clear, everybody? All right. And then number 2, use the formula directly. Number 3, use the formula directly. But some of you stop here. No, continue and simplify your answer. Okay, so let's take a look at the quiz mistakes. So that, by the way, the quiz mistake is on the website just next to the quiz 4. Okay, I hope all of you look at your mistake, and now we can improve in the exam. So here, miss the minus sign. Third quadrant, x and y both negative. Here, look at me. Make sure you draw the point on the xy plane. Do not just draw the triangle, because the triangle does not tell you whether the side is positive or negative. So you need to look at the quadrants. Okay? So be careful. And then here also miss a negative sign, and also simplify them. And yeah, here miss a sign. Okay. And here the secant negative x is just secant x. Secant and cosine is the minus. And then use the sum formula. Okay, the formula will be given. Yeah, here draw the picture. Figure out what is cosine s, sine x, cosine t, sine t. If you don't remember, ask me. And do not use your calculator. You're supposed to get exact answer. And also right here, we don't memorize these formula. So draw the picture, okay? Don't use this formula. Because in the exam, I don't provide this formula to you and you're not able to memorize them. And next one, the picture. And small mistakes, tangent 2 theta, sine 2 theta over cosine 2 theta, but then put the wrong number. Okay. So all the mistake is on the website. Please take a look, learn from it. Okay. Bye. Have a good day.
Hi, I just want to let you know.